Welcome back. In this video lesson, we'll be discussing another important aspect of chemistry, which is 2025 SSCE WAEC interpretation for question number 2 on salt analysis. We're dealing with two compounds, one organic, one inorganic, and then by analysis we are asked to mix the two salts, the two compounds together. I think the WAEC will always label that particular sample C, just like specimen C. In the last video, we have carried out analysis on A and B, which is your acid and base titration. Now, the extension of that is C, which is the source sample. As you can see, the source sample is a mixture of two compounds. That's copper 2 sulfates, copper 2 tetrasulfate 6, and then glucose. So we are to identify ions in this sample. Identify ions. In fact, what we are identifying here is copper. We also will identify sulfates. We will identify sulfates, and we also will identify glucose in this sample. Okay. In this video, we're also going to be stating step-by-step method to identify all of these ions from these salts, and all this identification must be in aqueous states. That means we must make a solution of this before we can be able to start to identify. And while we are making solution of this, we must also observe solubility, whether the sample is soluble, whether the sample is not soluble. And we're also going to observe the color of the solution, whether the color is brown, whether it is blue. All these things, WAEC doesn't joke with the color. WAEC doesn't also joke with nature of precipitates, and even if there is evolution of gas. Okay, all these things are things that you need to be very, very, very observant as far as number 2 is concerned. So we have our salts, we have our test tubes, have our test tube racker where the test tubes are arranged. We have our boiling tube. In the case of identification of simple sugar, glucose, since we have glucose in the mixture, that means we may be requiring some kind of form of heating to know if actually there is glucose. Okay, so we're going to see all of this in this video. Before we start the experiment, there is one part to this particular question part, which is the question is on the board. There's one part to it which I would like to explain the part before I will not put it in the table, just the way the WAEC will always ask students. They will say that every of your practical, your observation or inference should be in a table form under the subheading tests, observation, and what inference. So in every test you carry out, you must draw conclusion in all of it. Okay, now first you have a question like this. I'm going to carry the experiment live, but I want to show you the theory of what we're going to do, so you have a background of what we're going to do. C is a mixture of two compounds. You are not to know the compounds. That's number one. I shouldn't even in this video say that the compound is copper. If we need to identify it, then we'll now conclude from our findings that this compound is copper or the compound is glucose. So we don't need to know. That's why it is C. C means the mixture is unknown to you. So it's in the course of identification, then you now start to see some behavior of some ions, maybe exercise to start to see something going on in the test tube. And one can start to think, it look like this is a copper salt too. If on warming that something gives a brick red precipitate, it seems that it must be reducing what? Sugar. So all of these things you put it into consideration. That is when you now come into conclusion that it does look like this salt, these two mixtures must be a copper salt and a simple sugar. Are you with me now? But you are not to know the salt is copper sulfate and this. Maybe let's assume that we don't know, so that the experiment will not be more interesting. Just let's assume we don't know it. So we have to carry out exercise and draw conclusion in each test. Okay, now for me, I always say that we have a very big long. Let's make it very long. This is your boiling tube, your test tube, your first part of the test tube here. I think I'm going to use this first, okay, because I think we'll be requiring boiling. So we have this. So now you're going to ask to put some sample. You don't use big sample because too much sample can spoil your results. A solution, a sample that is meant to be soluble, if you use too much sample, it will no longer be soluble. It will be a case of saturated or super saturated solution. So use small samples that can easily saturate in a particular amount of distilled water you are using. So that is why you use small sample. Any amount of sample you use can still give you your positive test. So it doesn't matter when you use all this sample. Any sample you use can give you. So you're not measuring any quantity here. Some things you're using, you use your discretion when you're adding. So let me assume that I will add just small amount of C. Look at that C here. Like I said, we don't know. Okay. And they will like say add 10 cm of distilled water. See the 10 cm of distilled water. And they are asked to shake or stir. So by the time you shake, all this C here will no longer be here again. They will just disperse in this medium. And then here you have to now observe, after the dissolution of this C, is C soluble or is C insoluble? Based on solubility rules, all surface salts are soluble in what? Water. So it's expected that the salt will be soluble. You're going to see it soluble. The only insoluble sulfates are those of barium, barium, isn't it, and lead, and calcium slightly is insoluble. All other ones are soluble. So copper here should be expected to be soluble. But why they are interested in the color of the dissolution, and after the dissolution of that C, what is the color of the solution? So you also have to observe the color, and then also indicate that this is the color that you were able to observe after the dissolution. Okay, this is what you're going to be writing under your observation. So after dissolving, what did you see? So this what you are looking at is what you are going to be stating under your what? Observation. Do you get the point now? Now, let me also try to give you a background. Let's now, since we now know that the C is CuSO4 and then what? Glucose. Actually, glucose cannot split, but I'll show you how it will split. This one can split into what? Copper 2, and then what you're going to have here? SO4 2 minus. All these things are here. This one is here. This one is what? Is here. Glucose cannot split. Of course, you know it's C6H12O6, isn't it? But the active ion in glucose is the functional group, which is what? CH(O). There canal. It doesn't have minus, it doesn't have plus. It's just going to be here. That is why it is a reducing agent. The H here makes it possible to be a reducing agent. Okay, it's going to lose that proton. Okay, and what is oxidation in terms of hydrogen? Oxidation in terms of hydrogen, loss of hydrogen. If you lose this hydrogen, it becomes oxidized, because a reducing agent at the end of the reaction becomes what? Oxidized. I think I explained this thing in the class last time. So that is the reason why. So this thing is here as well. So there are reagents that we identify each of everything inside this place. That is why we now like, okay, you're going to divide this thing into 4 portions and start to identify each of every one of these. Are you with me? So the first portion here, let's say, you know how the portion will be like. So I'm going to have this test tube for first portion, next one for second portion, next one for fourth portion, and third portion, and then fourth portion. So I will take small, some maybe 2 cm of each of this solution here. Are you with me now? All of these things. Since I'm testing for copper, let me just pick only copper, but all of them are there. Copper ion. Are you with me now? If you want to precipitate this man, kind of try to bring it out from this solution, there is a reagent you can use to do that, which is, you can tell me the reagent that can precipitate it. If you want to precipitate this particular salt, hydroxides of copper, all hydroxides are insoluble. So if you want to precipitate an insoluble hydroxide from a salt, you use sodium hydroxide. So sodium hydroxide is going to do the job. So sometimes when you see this reagent, please, as far as this test is concerned, know that it's used to identify this cation. You will use it 2 times. You use in what? Use in drops and know what happened. If I add 2 drops, just 2 drops of sodium hydroxide here, moment I add 2 drops of this here, you will see a precipitate. Not just a precipitate. What is the nature of this precipitate? Why it doesn't joke with nature of precipitate? Sometimes precipitate can come in chalky form, cloudy, gel-like, like gelatinous. So copper 2 hydroxide aqueous solution is gel-like in nature. So what is the color of copper 2 hydroxide? Who can tell me the color of copper 2 hydroxide? Is what? No, it's not dirty. It cannot be. If you have dirty green, that means you are talking about iron 2. Light blue, very correct. Light blue gelatinous what? Precipitates. That is what you're going to see here. We're going to perform it. You're going to see it. So here, what are you going to see here? You're going to see what? Light. The light is very important. See, if you just say blue precipitate, you have fed it. The blue is not that. It is not that blue. It will not give you that kind of blue color, but it's good. Faint. It can. No, sky blue is not. It's out of it. It's light blue or pale blue, and the two things can only score. Any other blue again, you will not get it. Even blue, say, without putting either pale, you will not get it. So that pale is very important, or light. So once you add this in drop, you're going to see what? Light what? Blue gela. You must put gelatinous. Very important. Gelatinous. Please make sure you write this precipitate in full. The era of using PPT is gone. So this is what you have. This is what happened in drops. In drops. If you pour in excess, they want to know the nature of the copper hydroxide, because once you add sodium hydroxide, look at the equation here. Copper 2 plus NaOH will give me what? Copper 2 hydroxide plus Na plus. Look at it. Look at what you have. It's insoluble. It's an insoluble compound, isn't it? That's why it is precipitate. Now they want you to know there is types of oxides. They want you to know if this oxide is amphoteric, basic, or acidic. That's why they will ask you to add SS. If it is amphoteric, it's going to dissolve, but it's not part of metal oxides or oxide are amphoteric. It's not even amphoteric at all. It's basic. So that means if you add excess of this sodium hydroxide, precipitate will persist, or precipitate is insoluble in what? Excess. You are done with that particular test tube. You go to the next test tube. Next test tube, it takes more 2 cm. This time, now look at this now. If they say you should add barium chloride, who are you to identify here among 1 to 3? Sulfates. Why sulfate? Now look at the reason. Why sulfate? All tetraoxosulfates are soluble except those of barium. So barium chloride can precipitate insoluble SO4 from its salt. So the reaction is SO42 minus here plus barium chloride. What are you going to have if you have these two reacting? You're going to have barium sulfate, which is not soluble. So this is coming out as a precipitate whose color is white. It's going to come as white precipitate immediately. Plus again, anyone that comes out here is insoluble already. So this is what we are looking at, white precipitate. So the moment you add this man here, what happened here? You see white PPT. Are you with me now? But sometimes SO3 also will give you white PPT. Not only SO4. So to know that it is SO4 really that is here, you have to use something that can distinguish it. If it is SO3, if you add H, H is going to give proton to SO3. And this H will now form water. And then since this H combines here, what happens here is what? SO2. You start to see bubbles. And then the precipitate, if it's SO3, will dissolve. But if it is SO4, if you add HCl, precipitate will persist. That is the only way to now know that the ion there is what? SO4, not SO3. So you are going to require to add this, followed by this. So I think in this question, you can see it here. Where is it here? Second portion. No, not second portion. It's in the last portion here. So the fourth portion, add this, and then followed by this. It's just to know that this one is this. It is SO4 and not what? SO3. There is something again I'm not, I think I'm forgetting. Thank God I just remember now. So please, let's go back to the one on copper. You know, we didn't confirm copper here because there is something here on copper. Where is copper here? Whenever you see aqueous solution, please match it to copper identification. Whenever you see barium here, please match it with what? With sulfate. Whenever you see aqueous solution here, please match it also with copper, but this time is for confirmation. That is why you are having the fourth one. I'm supposed to do it here so that I match the two. I know that I'm through with copper, but let me match it here. So when you see solution from here, and you're asked to add NH3 in drop, NH3 is acting exactly as this. Whatever it gives you here, it is what it's going to give you. But only that it's not going to give you gel-like. It's just going to give you pale blue precipitate, no gel. No gel. It's just like a weak alkali here. That's why it's not giving you that gel-like precipitate. So if you add this, it's going to give you blue precipitate. Then if you add it in SS, copper is one particular element that can form complexes with ammonia, being that they are D block. So all complex ions are soluble. So you now see that in SS, the precipitate will dissolve, then give you a blue solution. That blue solution confirms that the ion here is what? Copper 2. So whenever you see ammonia in test analysis, it is used for confirmation of what? Cations. You can use it to confirm zinc. If it is zinc, you can use it to confirm, can use it to distinguish between zinc and aluminium. You can use it for most confirmatory tests. Most, not all confirmatory tests for ammonia. Then the last but not the least, that is one we are going to warm here. The one we're going to warm. So we're going to do it last, which is what? Glucose, isn't it? So if you have CHO, what we can use is a mild oxidizing agent. Why I say we should use fairly solution A, fairly solution B. Why you're using A and B? B is going to help A. Without B, there is no fairly. There are two different solutions. We add it one after the other. We add this one and check something, and add another one, check something. Then we warm. We need high activation energy for glucose to be what? Present. You know, most organic compounds, their reactions are very slow. We need to heat so that the bonds will break here. That's why we are warming. They are not like normal inorganic reactions that ions will just spear instantaneous. If you want this reaction to be positive here, it requires, after adding fairly solutions A and B, you must what? Warm. If you didn't warm, you will not see any red precipitate. Color that is like this. So all these things, let's match it with the practical. Let's see if what we are saying here, if we can see it here. And while we are doing it, we are drawing our conclusions immediately. While we are running the experiment, we are running it, we are just tabulating it just exactly how examiners or WAEC wants it, so how they will score, or how you attract mark. Any test you report it so you don't forget it. So we have first tests, what your observations are like, and your result as inference. So this is how it's going to be, and this is how it's going to be. So let's say I want to do question number 1A or 2A. So C. What is the state of C? Is it solid? Is it liquid? Is it gas? Yes, what's the state of the C? You must state it. What's the symbol for that? Would you write solid in full? No, now say S. Solid. Plus, they say we should add it. Okay, put in the test tube. So let me take some small sample in the test. Let's use this test tube. Okay, the sample this can do, and then we are asked to add 10 cm. If you didn't see anything to measure 10 cm, you can just add. Okay, this is 8 cm, so I can add 8 and take 2 later. So think I have to 10 now. So you shake thoroughly. You can use stirrer. You can shake to make sure that, see, you have to check because sometimes some soluble compound requires thorough shaking for those of them that are in lump form. So this is because some are lump, so we needed to, in this case, you need to grind using your mortar. There's some small mortars and pestle we have in the lab. I think they are dissolving now. So what is the nature of the dissolution? Can you say that this salt is soluble or insoluble? So what is going to be my, what am I going to write as my observation? No, now. What happened to C? C does what? Dissolved. There are two types of dissolution. Is it dissolved partially or completely? Dissolved completely. Completely. To give. What does it give? To give. What is the color of the solution? To give a light blue is okay. A light blue what? Solution. What's going to be my reference? C is a soluble what? Salts. Salts or what? Compound. Or C is a mixture. You know, it's a mixture. Why I say that is a mixture? I told you it's a mixture. So it's a mixture of what? It's a mixture of soluble what? Salts. Soluble salts or compounds. So, do you know we have just answered number 1A? So, you go to B. B says we should divide it into how many portions? 4. So that's why you have more than enough to divide. So, look for clean test tube. Sometimes they'll tell you 2 cm each. So instead of wasting time, you can use your discretion to guess 2 cm. So I can guess this as 2 cm. Okay, I think I've done justice to the sharing. So this was going to be the last one on identification of simple sugar. So let's start with this one. What do they say we should do here? Okay, to the first portion. See how I'm going to interpret the first portion. So now if I want to interpret this first part, I will just say first portion of C is now a solution, no longer solid, isn't it? First portion of solution C, from where did we get it from? From A above, because it was A that we got the solution. From A above. Okay. What are we adding it? What are we adding there? Okay, please, like I said, we're going to do this one last. So let's start with second one, which is what? Plus what? Plus, let's say I. So in this order. So let's say, what are we adding here? NaOH. In what? Drops. Then come down here. Don't try to drop an excess in the same line. Please, very important. And then what? Excess. Okay. Use another dropper. Where is our NOH? Let's add drop. Maybe any drop. Maybe if you try one drop, if you didn't see anything, you try two. Are you seeing something? This is drop. So what did you see? Okay. Okay. So look at this. Don't go down. Look at this. What you are seeing is, what is the color? Pale now. It's not a sky blue. But we don't use sky blue. We call it what? Pale blue. And it's gel-like. So it's stated like that. So what I'm seeing here in drop, please go to the line where you have drop. Please leave this space here. Just match the drop. And you write what? Pale pale what? Blue gelatinous precipitate. Shift this excess, go down here. What happened in excess? You write it down. So the only ion that will give you this particular color with this particular NaOH is what? Copper 2 ion present. There is no competing ion here. Okay, let's see what happens if we add it in excess. In excess of the alkali. In excess the precipitates is, there are still precipitates. Well, it does look like it's dissolved, but it can't dissolve because it's not this. So please still write in excess of this same reagent. You now say right, pale blue gelatinous precipitate insoluble. The word insoluble still means does not what? Dissolve. Insoluble in what? Excess. What else are you going to write here? Copper 2 ion present. We are done with that particular test. The next test,